Welcome, everyone, and thank you for attending another PyLadies London meetup. Today I have with me Katarina Šupe. I hope I said that correctly.
Yeah.
And she will be speaking to us about graph-based stream processing in Python. So I will hand it over to Katarina. Katarina said that you can unmute yourself and ask questions at any time during the talk, or if you prefer to type your question in the chat, you can also do so, and we will have a Q&A after the presentation. Just for housekeeping and to not distract the speaker, please remember to keep yourself muted when you're not speaking or asking a question. And yeah, now I will hand over to Katarina.
Thank you, Anna. So let me share my screen. Okay. And I'm hoping that everyone is seeing this okay.
Yes, we can see it.
Great. So today I'm going to be talking about graph-based stream processing in Python, like Anna already mentioned. This down here is a little bit of teaser of what I'm going to talk about. So first, let me introduce myself. My name is Katarina, and like Anna said, Šupe, so she pronounced it well. I was born at the Croatian coast, so in Croatia, a little coastal town of Šibenik. I did my master's in mathematics and computer science at the Faculty of Science in Zagreb. Zagreb is a capital town of Croatia, and I'm currently living here. I work as a developer relations engineer at Memgraph, so I'm not sure if everyone is familiar with the role in Croatia. Not a lot of people know what developer relations is. So I'm actually communicating with lots of developers on my day-to-day job. So I'm listening to them. What do they want from the graph database? What do they want from Memgraph? And I really want to help them so that we can implement stuff they want to make it easier for them to use our product. Also, I added this engineer part because I do a lot of coding. I'm writing lots of demo applications and also working on an open source project called ksqlDB, and I'm going to talk about that a little bit further on. Also, like probably everyone else, I love to travel, cook, and eat tasty food. Check out my Instagram because I have lots of food on Instagram, and that's it. Here is my link to the link tree, and there are lots of my social media, social networks like Twitter, Instagram, something like that. But I'm also writing blog posts on Medium because whenever I do some kind of application, I like to write what I did there, some kind of tutorial. Of course, it's probably not the perfect one, but I'm trying to write it because whenever I'm doing something, I'm always Googling stuff and finding solutions online. And I just wanted to give back to the community, like write also my piece of tutorial. And if someone thinks that I'm doing something, that I should do something better, then of course, good constructive feedback is always welcome. So yeah, that's it about me, I would say. Now let's jump into the topic. So first, I would like to introduce you a bit to the graphs, to the graph data model, graph databases, in order to know about what I'm talking about. So to get to know with the graph streaming, you should know about graph databases. And I'm not sure how many people are even familiar with that subject. So I will just give you a bit of intro. And if you have some kind of question, something is not clear, you can always ask me. So the graph data model. First, let me explain the difference between graph databases and relational databases. I think probably most people are familiar with relational databases. So those are some kind of tables, and they are not connected at the beginning. So in order to connect them, you have to do some kind of select, join, something like that. But on the left, you can notice that this data is already connected. So in graph databases, you have highly connected data. And in relational databases, you have tables which have to be joined in order to connect them. Also, one other difference I would like to mention is that on the left side, you have graph databases, and these databases are prone to change. So if you have, for example, some different kind of customer that doesn't have some, for example, it has name, it doesn't have last name, something like that, you can always change that a bit. So you can change its schema. But on the right side, you have relational database, which is not that prone to change as graph databases. But also you can ask yourself, why would I even want to use graph databases when I have relational databases? So actually you would use this kind of databases if joins are problems. So if you have many-to-many relationships, for example, you have users that are friends with each other. So lots of users are friends with lots of other users. You have lots of joins that are complicated, and then your querying is also complicated. But in graph databases, there are perfect example. Perfect use case are some kind of social networks, because you have many-to-many relationships and they are already connected. So you just traverse the graph with on these relationships. So that's like the main difference between graph databases and relational databases. Okay, but what are graphs, if you are not familiar with that term? So in mathematics, actually, you have graphs as a structure, but also here graph is a network structure that consists of set of nodes and set of relationships connecting them. So you can notice a different kind of naming convention here. Maybe you heard of vertices and edges, maybe you heard of nodes and edges, some kind of combination of those four. Us mathematicians are wrong, guilty of this vertices and edges part, but you can call them however you want. But in this presentation, I will try to give them nodes and relationships so that you know what I'm talking about, but it's not that important. So on the right, you have a different kind of nodes. So here, a node has a label, and label is person or city or location. Okay, so a person also can be connected to another person or can be connected to another city. And you can notice that this connection is called married to or lives in. This is called type of relationship. Also, person has some kind of properties. These properties are, in this example, name and date of birth. So if you are familiar with the relational databases, you would have some kind of table that is named person, and this table has some kind of headers with name, date of birth, and you would fill the rows of those tables. Also, a relationship can have a property. So for example, here, married to relationship has wedding date property. Okay, now this is really good example of what I said before, why it would be better to use graph databases in this kind of person-to-person contact. So for example, if you have married to relationship and this relationship is saved and it has property wedding date. So if you were looking for all the persons that are married on this date, you would only look relationships with these properties. In for example, relational databases, you have some third table that's going to have a person's ID. So like first person ID, second person ID, then wedding date. And then you would have to create this table, join two tables to create this table, and then match it. So this is kind of a different kind of thing you are doing here. It's not always better to use graph database. Sometimes relational database is better. So that's why I'm going to talk about use cases where the database is better to be used. So how do we even communicate with the graph database? Mostly we are using Cypher query language. So Cypher is most widely adopted. You have other languages for querying graph databases. It depends which graph database you are querying, but Cypher is most widely adopted. It has clauses such as match, delete, set, return, and functions, and also custom procedures. And these custom procedures can be written in Python, C, C++, and Rust. Now to just compare these two. So on the left, you have Cypher query, and on the right, you have SQL query. So this is actually the same query. So we are doing some kind of product recommendation here. On the left, so you are looking for a customer that has bought some product, and you are looking for another customer that has also bought that product. You would say that these two customers are probably similar to each other. And then you are looking for all the products that other person bought. And you want to get all the products that other person also bought, but the first person hasn't already bought. And this would be some kind of totally simple recommendation. And this would be, so 1, 2, 3, 4 lines in Cypher. On the right, you can notice that with the SQL, you have to do lots of selects from, join, where. So it's just kind of messy because you are actually looking for relationships from different kinds of tables, and you don't have them in the start. So this is a good example when graph databases is actually working better than relational database. Now, let me tell you a bit about graph analytics, because GraphStream will be based upon that. So it's also called network analysis, and it generates insights hidden in the relationships of the network structure. It uses specific structures to represent entities and graph-specific algorithms to analyze the relationship among them. So I'm going to tell you a bit more about which kind of algorithms you can have. You can implement them in Python or any other programming language. So let me dive into that. You are familiar with these companies, and they all notice the strength of graph algorithms. They are using it, and you are noticing its impact on day-to-day basis. So for example, when you are searching something on Google, the first result that comes up is the result that has the highest page rank. That is calculated with the help of PageRank algorithm. Also in Facebook, of course, like a social network, you have community detection. This means that you have different kind of communities, and then you can recommend some kind of content to this community. Also, you have some kind of link predictions in order to recommend friendships or something similar to that. In Amazon, collaborative filtering is a popular method of doing recommendation, and so on. So like I already mentioned, social networks are a really good example. You have user, this is how the graph data model for that would look like. So you have a user that is friends with another user, and then based on that relationships, you can determine different kind of communities with graph algorithms, of course. And also you can calculate link prediction. That's also, you are also calculating that with the different kind of algorithms, for example, node to back or something else. And with the help of those link predictions, that's actually like you are predicting a new relationship in this network. This means that you can do friends, like recommend a new friend to some user. This is actually showing us first how social networks are really strong, because here are all the users and relationships between them are highlighted. But also it's showing us how graph databases are actually intuitive, because when you are thinking about users and their relationships, you are actually drawing a graph. You are drawing nodes, and you are drawing relationships between them. Another popular example is recommendation engine, and you are probably also doing this every day. At least I'm always binging Netflix or something similar. So movie recommendation is really popular in graph analytics, because you have this kind of great data model, and you have some user that rated some movie, and this movie is of some genre. So you can find similar users that rated same movies, and based upon that, you can recommend them another movie. So this is a really good example of graph analysis. Another example, maybe more business-like, is supply chain management. So here you have some supplier, and in the end you have retailer. So supplier supplies this product, and this product needs to be distributed. So in this way, you can easily detect a weak link in the supply chain management and act on time. So if something goes wrong, you can fix it and deliver on time. Therefore, you can do some kind of business risk analysis. Oh, sorry, I'm not sure why this isn't showing. Okay. So fraud detection is not showing, but I can tell you about it. Fraud detection. So you can do different kinds of fraud detections. You can have a card fraud detection. You can have, for example, insurance fraud detection. And there you can do different kinds of graph traversals. So you can determine shared resources in previous frauds. You can do graph centrality, where you can find influential individuals, or maybe the most popular one would be to determine communities, like fraudsters who are working together. Okay, yeah, I'm glad that the next slide works. I think the photo didn't load on that one. So I talked about the use cases of graph analytics, but how you are actually doing them is with the help of algorithms, graph algorithms. And these are the examples of the most popular ones. So on the right, you can see on the above photo, you can see how would you visualize the community detection algorithm, for example, because here you have nodes belonging to the same community are colored the same. Or on the photo below, the nodes that have larger page rank value are larger. So because they have more connections coming to them or from them or something like that. So in that way, you can determine some influential person, for example, in network. And this is where Memgraph comes from. So the demo I'm doing that I'll show you, I'm using Memgraph not only as a graph database, but as a graph computation on streaming data. So this is now lots of words, but let me explain that a bit. So graph computation here would mean I'm actually doing graph analysis with some graph algorithms. On streaming data means that this data is streaming from somewhere, like coming from real-time source or something like that, powered by an in-memory graph database. So it's in memory, it's not on disk, it means that it will be faster. So as I already said, it's not used only as a database, but also it has its whole ecosystem. So maybe the most interesting part for the Python developers in this ecosystem would be Memgraph's drivers. So you can write in Python and connect to Memgraph, but also the thing that we are currently developing is GQL Alchemy. I'm going to tell you a bit more about that. And also you can notice below Mage, so our little wizard. This Mage actually means Memgraph Advanced Graph Extensions. It's also open source repository. So we have GQL Alchemy and Mage as open source repositories written in Python. So Mage is actually a library where you can find different kinds of graph algorithms. So implementation of PageRank, community detection, and similar to that. And GQL Alchemy is a Python library. It's an object graph mapper, and it represents a link between graph database objects and Python objects. So if you have worked with relational databases previously, you maybe know of SQL Alchemy. It's an object relational mapper. So we are building something similar to that, but just for graph databases. So it has OGM capabilities, query builder, on-disk storage, and graph schema validation. This on-disk storage means that actually we are offering you to save some parts of the database on disk, like on some SQL, something like that. And so that when we do calculations in the database, you don't have to have everything stored, but only the data that you are doing calculations on. And this saves a lot of time, and then the analysis is more efficient. Okay, now I'm going to show you what I did. So the Twitter data set. We had a little project at our company. We decided to do, in our team, we decided to do a little demo during the Christmas time. So we scraped the data from Twitter using the hashtag Christmas, and we wanted to find out who was the most Christmassy person. It seemed cool to us for the Christmas time. It was fun and really cool project to show the streaming graph analysis. First, it's social networks, so it's a great example of graph database usage. Next, it's also, you can do streaming data, so it's fun to notice the changes in the network once the data comes. So we decided to do dynamic PageRank algorithm. This dynamic part means that we have different kinds of implementations of PageRank. One is static, like it's on static data. Other one is dynamic, and this one is for when your data is streaming and you want to do your calculations quickly. So dynamic PageRank is used to find the most influential account, and community detection is used to figure out which accounts belong to the same community. Now, as I already mentioned, you have to first create the data model for your data. And this is a really simple data model. So you have a user retweeted some other user. This user only has its username. It will get other few properties once they are being calculated. So it will have rank property for PageRank, and it will also have a cluster property for community detection. Now, let me tell you a bit about graph stream processing and what we are actually going to do. So all the data that is coming in real time, we are going to analyze. So we are extracting additional information from the data as it's being consumed. So we are not waiting, okay, let's put all the data in our database and then let's calculate PageRank, community detection, whatever you want. But as the data comes, this data is being processed and you get the results, new results in no time, because these are dynamic algorithms. So what actually happens, like I already said, you have input data. This data comes into stream processing engine. Here, Memgraph plays as stream processing engine. And then later on, you get the output data and you can later on analyze it. You can do whole web applications, so you can show it on the front end like I'm going to do. You can do analytics, send it somewhere else. You can draw charts, something like that, whatever you want to do with your data. The important part is quickly analyzing the real-time data. So this was my architecture of the application. I had this scrape data as a data source. You can do real-time data source, like not scrape data, but this is a good simulation of what it would look like, because currently I think if I turn on the real-time, that Christmas Twitter wouldn't be that popular. And this data is being fed into Kafka. So then Kafka is a message broker that streams data into Memgraph. Memgraph does the analytics on each new data, then it sends it back to Kafka, and then Kafka sends it to our backend server. This backend server is built with Flask and Python. And so with the help of that backend service, we are connecting to Memgraph. We are consuming Kafka messages. And then in the end, we are sending it using the socket.io library through the WebSocket to the front end, to the client. And this client is built with React and D3.js. This is, if you are not familiar with that, JavaScript visualization library, and it's really good for documents. It's really good for this kind of data and drawing graphs. Also, you can notice a direct connection between Memgraph and backend server. That's because you can always query the database for whatever you want, because if you don't have that kind of data streamed, then you can ask it directly. For example, I want to all names of all users that are currently in the database or something like that. Okay, now demo time. Let me just fire up the app, just a second. And I'm going to show you here how it looks like. So right now, I can show you what's happening in the background so that you are aware of. If someone has questions or something that it's unclear, I know I mentioned a lot of terms here, but feel free to ask. And I'm currently building the backend, whole backend starting Memgraph, backend Flask Python server, and Kafka as a message broker. And next, I'm going to fire up my front-end app. I'm also I'm like a full stack, but I'm learning everything. So I was more keen to the front-end side, but also it was fun building the backend side too. So I was really proud of the visualizations, and I'm hoping that the WebSocket will work now. Let me just, okay, this is up, and I'm waiting for the React application to start up. That's taking, okay, now it's built. Let me show you. I'm hoping that you're seeing this. Okay. So this is the applications, and here we have PageRank and community detection, and this will, okay, it works. So as you can see, this will start coming up. Okay, I have messed up something. That's great. I can fire it up again. But the important part is that you can see that the nodes, the size of the nodes is being changed as the new rank is coming to the network. So yes, here. And down here, you can see the community detection algorithm. This algorithm will do what it will do. So the colors of nodes will change in time when a new information of a new community comes to the network. So this is not happening that often. I'm hoping that it will happen sometime soon. But yeah, you have these nodes. They are together in some kind of network. Yeah, now you can see the colors changing. They are all belong to, yeah, that's it. So, yep. And this is the PageRank. This is like, you have the most influential one is the largest one connecting to the other nodes that are not that important. And you have community detection that also painted these nodes in another color. Okay, let me now turn this off and tell you a bit what we need to do in order. Let me shut this down. Okay. So what I did to make this work. So I created a transformation module in Python. I ran the PageRank and community detection algorithms with GQLAlchemy, create and start stream with GQLAlchemy, and create a trigger module and send PageRank results back to the topic. Okay, so let's dive in. This is actually written, this is a code snippet from Python, and I can show you later on if you want. I can open everything up in Visual Studio Code and show you where this is located so that you know how the application is built. Whole application is built with Docker and Docker Compose, and it has Memgraph, backend, frontend, and stream services. And here we have something that is part of Memgraph service. So what transformation module does, it actually translates the messages that are being streamed to the query. So Memgraph needs to know what it needs to does on each message, and this is what does that. So when you have this kind of module, you are saying, so with these parameters, you are receiving some kind of tweet dictionary, which has source username and target username. And you are telling to Memgraph that it needs to create this kind of query. And this query, what it actually does, it creates two users and relationship between them called retweeted. So this first user retweeted another user, and in this way, Memgraph knows what to do. So that's the first thing we need to do. Next up, we have PageRank. So we have PageRank and community detection, but actually the call of those two is pretty similar. What we have here is a lot of Cypher code, you can notice, but actually now we are working really hard on GQLAlchemy, and we have created lots of parts to make it an OGM, but we want to improve on that. We want to improve with the OGM, we want to improve query builders, so the next thing would definitely be to turn this into something that it's more Python, less Cypher, and it's an open source project, so whoever is interested in that kind of stuff could always contribute. So here we are calling the PageRank online. This means that it is a dynamic algorithm. We are setting everything up. We are creating trigger. This means that whenever there is an update on rank property of node, then that the publisher update rank will be called. What this publisher does, this is a Python script, Python method that will actually create a new Kafka producer, and it will send new messages to a certain topic. We are sending all messages to the same topic. So whenever PageRank is updated, whenever community detection is updated, and whenever a new node is created, we are sending that information to the same topic. That information is being streamed. And then in your backend Flask server, you need to create consumer and this consumer receives messages from that topic, and you are sending those messages through the WebSocket to your client. Okay, so what we have to do in order to create this stream in Memgraph, you have to create this instance of Memgraph Kafka stream. So here we tried a bit more. So this you can also write with a big Cypher query, but this is now a little bit more Python-like. This is a part of ksqlAlchemy, where you can create Memgraph Kafka stream, give it a name, topics. This transform script is actually the first one that I showed you. So this will tell Memgraph to look there when receiving messages from Kafka. And next you create and start streaming. We have to create a trigger for, I created trigger a few slides before for every PageRank update in the same way I created for community detection. But for the creation of object, here trigger is created. In the end, this is a bit different, but yeah, in the end, you have this kind of results. So PageRank, like I already said, the node is larger if it's more influential. And on the right side, if the nodes are colored the same, they belong to the same community. Of course, if I receive that kind of information, then it will be colored the same. So yeah, I'm hoping that I didn't forget a lot of things. I wanted to say a lot of things, but in the end, this is all implemented in our GitHub repository, which you can check. I will send you also the links in the chat. Also there we put like a few days before we decided to put everything up in our sandbox. That's our playground. The data set will be uploaded there, so you can go there. You have like a live query editor, and you have some kind of sample queries, and you can play with it. You can see the data model, you can write your own queries, and you can see what's there. So it's like a good playground, is a good way of starting to learn how to play with graph databases and how to get great data from it, great insights from it. And in the end, you can join our Discord server. So me and my colleague are running it since we are developer relations. People are coming there. Lots of people came because we had some kind of graph analytics for Python developers course. And all the materials are still there online. And we are always there to help if something is needed for that kind of course or something else. We are really Python concentrated in Memgraph, and lots of Python developers are part of our community. So feel free to join. These are my contacts. If you want to follow me on Twitter or ask anything, you can send me email, send me message, whatever, whichever channel you like. And also, I didn't add slide here, but I will send you the link. We have job openings for software developers in Python. So actually we have another team that it's called solutions team, and they are doing lots of stuff in Python. They are working with clients, and they are building data models. They are building the whole solutions in Python for those companies. And I think that it may be also interesting for people who are keen to graph analytics, or maybe doing research about different kind of graph algorithms, and then later implementing them in Python. So if anyone is interested in that, the role is totally remote, so anyone can apply. And I will send you the link to the open position, so you can feel free to check it out. And yeah, I think that's it.
Great. Thank you, Katarina. That was a great presentation. I just looked at the Memgraph careers page, and I do think I found the position you talked about, so I posted the link.
Yeah, you did.
Yeah, okay, great, cool. Do we have any questions? If yes, please unmute yourself and ask a question, or please post it in the chat.
Yeah, you did send the good link. I checked, so this is that position. Yeah.
Wonderful, great.
Yeah, I know it's probably a lot. Like I didn't know how to put it all in one presentation because it was a whole web application. But if someone wants to see like code, what we did in Python, I can show it to you. I'm not sure what do you want, but if someone has any questions, yeah, feel free to shoot.
I think it was a great presentation. I like that it was very visually pleasing. I like the code examples, and you did really well. So thank you. Thank you. Last call for questions. If you don't have any questions now, I think you can also contact Katarina via the means she mentioned. And as always, this will be posted on our YouTube channel afterwards, so you will have the whole presentation and you can rewatch it. Okay, Deidre says, great.
Thank you.
Katarina, amazing presentation. Would you be able to share your slides? Yes, if you send me the link for the slides, I will send them out as well. Okay, great. And I will say thank you again, Katarina. Thank you everyone for joining. Next month is International Women's Day. And we have a very special meetup planned with the PyLadies Dublin. So watch out for an announcement from me either tonight or tomorrow. And again, thank you for the great presentation. Have a lovely evening, and I will see you all next month. Thank you. Take care, everyone.
Thanks.